Okay, so this is question 6 from the mechanics part of the maths paper 2019 for OCR. It's a momentum impulse question which needs to be taken carefully because it's all about string becoming loose. It's in 2 dimensions and we need to take a bit of care to set it up properly. Initially we've got M, which is, A, which is of m kilograms resting on a table, and B, let's put it a bit closer than that, B, which is of 1 kilogram, resting with d over 2 between them, where the length from here to here is d over 2. Okay, and what's happening is it's been connected by a string which is of length d, so obviously it will be loose at that point. And B is projected upwards with velocity, with speed v in a direction perpendicular to AB initially. Right, so clearly what will happen is it will move upwards here in that direction until it reaches such a point where it becomes tight. So in other words, at such a point where the length from here to here is the length of the string, so that's d from there to there. Let's mark our new position for B there, and at that point the velocity is v in a direction to the initial B, which are perpendicular to the initial AB. So it's going up with speed v there. Right, well clearly we can work this angle out because it will be equal to 60 degrees because it's just simple SOHCAHTOA really, adjacent over hypotenuse, so cos of theta is equal to d over 2 over d, so that's equal to half, so that it's easy to get that angle as 60 degrees. Okay, now the key to solving problems like this, remember this is initially at 0, is to resolve this velocity into the 2 components, parallel and perpendicular, parallel and perpendicular to the string. So let's do that. We can mark in the angles here. Right, so clearly this angle here is 60 degrees here. That angle is 60 degrees. So we can split this into 2 components. This component here will be equal to v sine 60. So that's equal to v the square root of 3 over 2. And this component here, the component which is perpendicular to it, will be v cos 60, which will be equal to v over 2. The key to this kind of problem is to appreciate that the impulse that will act upon it will be obviously in the direction along the string, so it will have no effect on this component. It will just change this component. Okay, let's just write this as our before situation. So this is basically going with speed 0 in this direction before, and then afterwards what we'll have is the A will go with a velocity, B will go in a direction there, let's call it v dash, which is the new velocity in that direction for B, and obviously A will carry on, will have the same component in that direction because the length of the string is, because it's connected by a string, but the thing is this will be unchanged, v over 2. Okay, so we want to find the impulse acting on the string, but in order to work that out, we really need to work out what v dash is. Let's read out that as v dash. So let's write out momentum equation, conservation of linear momentum along line of string. So the only thing moving is this part here, so that will be equal to v sine 60, which is v the square root of 3 over 2 times by m, and m is equal to 1. Okay, and this is not moving, so there's no velocity of that part, equals to v dash times by 1 plus m times by v dash. That's the velocity of this bit here. So that just gets us an expression for v dash. So v dash is equal to v the square root of 3 over 2 times by m plus 1, because clearly we can write that as v dash m plus 1 there. So that's our velocity in that particular direction, the common velocity of A and B. And then we can imply impulse. Impulse equals change in momentum. So, in momentum. Now the thing here is that the momentum, we could talk about the change that's happened to this in that direction, but wouldn't it be easier, because this was stationary before, to just say that's equal to m times by v the square root of 3 to m plus 1. I don't think you need to, but just in case, because it's so that we could put m times by 0 there. So that gives us the impulse is equal to mv the square root of 3 over 2 m plus 1 as required. Now, a lot of people got a bit confused with this question, because really I suppose it's worth mentioning that this is what is this velocity here, and the impulse is that it is part of, and it's involved with. That's the initial velocity as a result of this sudden kind of impulse jerk in the string. What happens after that, because it will not carry on going with velocity v dash in that direction, is far beyond the course. So we're talking about what the change of velocity is as a result of that initial kind of impulse in the string. And then after that, one will pull the other along, but that's not part of the question, and it's also not part of the course. Okay, so the second part B, is about finding the kinetic energy of B, K of B. Now, this should be reasonably straightforward now we've done part A, but the main thing to remember is that we've got two components, because B still has the component which was perpendicular to the line of the string. So the kinetic energy of B, remember it's only got mass 1, so there's no m in the formula, so it's half times 1 times by v over 2 squared, that's the unchanged component which is perpendicular to the string, plus half times 1 times v dash squared, and we know that v dash is equal to that, so we've got v the square root of 3 over 2m plus 1 all squared there. Okay, and they do what we do need to write as a single fraction to get the full credit for that. So this is v squared over 8. This will be equal to 3v squared over 8m plus 1 squared. So we can put that over common denominator, and because 8 is a common factor and so is v squared, so we've got v squared over 8. And then we've got m plus 1 squared plus 3 all over m plus 1 squared. So that gives me v squared over 8. And then we're going to have m squared plus 2m plus 4 on the top, and m plus 1 squared on the bottom. That's it. Okay, it says a single fraction now. Right, so that's the kinetic energy of B. That's reasonably straightforward. The tricky part was part A, split into components and whatnot. And now we, as they really like to do with the new spec, and they always have done to be honest, want to do a bit of interpretation, a little bit of modelling. 2 marks. It says, in the case where m is very large, describe with justification the approximate motion of B after the string becomes taut. Well, the key, as m gets large, look at this expression here. M is on the bottom, so as m gets large towards infinity, v stroke tends towards 0. And what does that mean? Well, it means that the velocity is of B will be perpendicular to AB. So velocity approximately, or speed, will approximately be perpendicular to string AB. Okay, so if we've got now this being perpendicular with v over 2, it would be, because this bit is now gone towards 0, and this is our A and this is our B. This implies that the motion will be circular. Approximately circular. Now, I always think, well, there's 2 marks here, so I think we've probably got enough, but let's just say centre A, radius would be equal to D. Whether that's in the mark scheme, I'm not sure, but we don't know we don't have the mark scheme when we do the questions, so I think, I would always be cautious. Give as much information as you can, because there's 2 marks anyway. Okay, so that's question 6, Impulse and Momentum 2019 OCR Mechanics, Further Maths. Thank you very much. Bye.